Okay, so now we finally go to your presentation 3, the final presentation for this session. Um, so let me show that screen. So this is the screen of your presentation 3. So module 1, presentation 3. Tectonic plates, earthquakes, volcanoes, and mountain ranges. So here's the map of the surface of the Earth, and we know that these are the uh, we know that there are tectonic plates somewhere in the map, but how do we know where they are? Well, we know them because scientists have gathered data from earthquakes, volcanoes, and mountain ranges. So this is what they saw. If you plot out all the active major volcanoes right now, you can see all of them in the map. And then if you look at the earthquake epicenters, where earthquake happens, each dot there is an instance of an earthquake. That is what you see. And if you actually superimpose both earthquakes and volcanoes, you have this pattern where they seem to go together. Where there are earthquakes, there are also volcanoes. There are some places where there are only earthquakes and not volcanoes, but wherever you see volcanoes, you always see earthquakes in them. Okay? Now, if we go to this activity, you can actually highlight where the volcanoes are. You can also highlight where the earthquakes are, and then you can superimpose both of them. And if you look at where the plate boundaries are, the volcanoes and earthquakes kind of actually make a layout of where the boundaries are. Okay? So that's one of our earlier findings of knowing where the boundaries are. Okay? If we go to the next slide, these are the major tectonic plates: North American plate, Eurasian plate. So we have discussed that already, and also the minor plates. Now, third one is about mountain ranges. Where are the mountain ranges? So we have the Rockies here. Let me play that back. You have the Rockies in North America, and the Andes in South America, and then you have the Alps somewhere here, and then Himalayas, and then mountain range right there. And then if you notice, do they also trace out the edges of the tectonic plates? Well, let's see. That is edge of North America, edge of South America, and then this line is somehow cutting the two landmasses, the African landmass and the Eurasian landmass, and then somewhere here on the edge. So if you look at where the plate boundaries are, well, those are the boundaries. The Rockies, Andes, you have the Alps somewhere here, and then you have the Himalaya somewhere here, and you have the other mountain range here. So you see, they follow also the edges of the tectonic plates or the tectonic plate boundaries. Okay? Now, the final nail in the coffin that really sealed the deal for us was this invention of the Global Positioning System of Satellites, or GPS. So we have a lot of these satellites flying over the Earth, and we can actually track very small movements of the land. And even if we already had an idea from earthquakes, volcanoes, and mountain ranges, it's still a good feeling that it was confirmed by a modern technology, which is the global positioning system of satellites. So before we relied on volcanoes, earthquakes, and mountain ranges. Now we only look at global positioning satellites, and we kind of know where the plate boundaries are. Okay, so I think that would be it for presentation 3.